Hi everyone. In today's video, I wanted to showcase how you can take control of your SQL learning journey. If you want to learn SQL and really do data analysis, there are many options out there. And there are so many resources that are available where you can learn not only how to write SQL queries, but what kind of data analysis you'd like to do. There are different data sets out there, setting up your own Postgres database or any MySQL, Oracle, any database. The information out there is a lot. And in my conversation with students and people who are beginning their SQL learning journey, what they've told me is they get very overwhelmed. And I can understand. It's very hard to put together all the resources that you need and then get started. So in today's video, I want to showcase a few items that can really make it easy, or at least relatively easier than doing and putting together so many items before you can get started. So the few things that you will have to do, right? And of course, you will have to put in some effort. But as I show you in this video, that is comparatively much less than the other aspects of setting up a database, setting data sets into it, then figuring out SQL queries and so on. And one big component in this video is going to be the use of ChatGPT as a tutor and as an entity that can sort of work with you to write SQL queries and also learn about SQL from scratch. So the first thing I wanted to actually showcase was a Docker image that I put together. For those of you who don't know what Docker is, in a very simple definition, imagine you have a platform, right, which is your computer, and the equivalent of that is a phone where you have a Playstore or a App Store, and then you go and download apps. Of course, the metaphor doesn't carry completely, but Docker is like an app store for you to be able to download or use any kind of software. Tomorrow, if you decided to run a particular, I don't know, let's say Python 3.9 or 3.10, of course, you could just download Docker. If you wanted to try another programming language like Golang, you could use a Docker image and start experimenting with Golang. This is sort of solving the problem where you have to mess with installing software on your PC, and Docker sort of takes away that problem. So what I've done is I've created a Docker image. We can easily create a Docker image by writing a Docker file. And in that Docker file, what I've done is I've created a Postgres database and inserted data from a very popular dataset available on Kaggle called the Google Playstore Apps dataset. I'll show you what it is. And once this Docker image is made available, I created a account on Docker Hub and put it up there for all of you to use for free. So if you go to the URL here, and I'm going to link all of that in the YouTube in the video's description, you will see how to get started. Once you have Docker installed on your PC, you could fire up your terminal. I have a Mac. You might have a Windows PowerShell, I guess, on Windows, and terminal on Linux. And you can power up this Docker image, right? Once you run this Docker command, if you don't have the image already on your computer, it'll download it and it'll start the image. And then once you go to the URL localhost 8081 in your browser, you will see a screen where you can type in all these values, and it will let you in to this interface, right? This is PgWeb, another component that I added in the Docker file. Maybe I didn't mention it earlier. There's a Postgres database, right? Then there's data inside of that Postgres database from Kaggle. And to interact with the database, there's this SQL editor that connects to the Postgres database called PgWeb. It's a very popular open source Postgres SQL client, and it's part of that Docker image that I've created. And once you come here, right, you can see that I've already preloaded this data set to what you observe on the screen right now. And it has a few columns, the app name, category, adventure app, maps and navigation, personalization, the rating and count of ratings, number of maximum installs, whether it's a free or paid app. If it's not free or it's a paid app, what's the price? What's the currency? I think this is the size in megabytes. And when was it released, right? Of course, the actual data set on Kaggle is pretty large. I've taken a sample, a random sample. And this is what you sort of get when you click on the table name. It sort of extracts the first few rows and displays it here. You can also go and look at the structure. It tells you the different column types and column names. And here's a query editor. Okay. Now let's see what you get when you write a simple query. So select star from Playstore app. Okay. Just limit. Usually it's better not to write select star. As you learn SQL, you'll learn more about why select star may not be the best way to look at a sample data set. But we'll just run with it for now. Right? Okay. Now, what's so different about what I'm exploring here, right? I think you also have to sort of realize that today with ChatGPT, you can have a tutor that's available to you all the time. But there's a way to use ChatGPT, right? So let's go to ChatGPT and see what we can do. The first thing I did was I wanted to, prompt GPT, and I'm using GPT-4. I wanted to prompt GPT-4 eventually for becoming a SQL tutor, right? So tutoring me on writing SQL and doing so for the particular data set that I have. But I wasn't able to provide the context to the tutor. And the way you provide context to ChatGPT is to say how the data set is structured. What I mean by that is, how does this data set, how can you describe this data set, right, to ChatGPT in your prompt? The idea is that if you want to, let's say, learn 5 or 6 beginner SQL queries on this data set so that you can run on this data set and get the results and play with it, the query should reference this table name, these columns, so that when you actually run it here, it works. But then how do you tell ChatGPT what this table is all about? So what I did was I went to this particular interface and took a screenshot. I just did this. And because I'm using GPT-4, came back to GPT-4, I just sort of pasted it here and said, provide the SQL create of the table in the image. So create table as is what I had already executed when I created the Docker file and then inserted the data into the Docker file. So I could have just taken that, but let's say you guys don't have access to it. So copy paste that screenshot of the table, the output table, okay? And then ChatGPT gives you the create table command. Well, all of this is correct. It probably didn't get the table name right because it was not in the screenshot, but that's okay. We could change that when we actually. So I have the table name. I have all the columns and their data types, which is exactly what you write when you create a table. Okay? Now I'm going to sort of copy this, okay, and go back to ChatGPT. I actually started playing with this already, but let me start a fresh one. So I can say, given the create table query below, write 5 SQL queries for a beginner who is looking to learn SQL. And after 3 hyphens, provide this. Okay. So GPT-4 says, all right, select specific columns, filtering results, nice. Aggregating data, very important. Sorting results, combining, filtering, aggregation and sorting. It sort of gives you the first 3 or 4 very simple ones and then gives you a fifth query that combines a few of the concepts that it. But let's try this. We'll make one change. I think the app, the name is slightly off. We'll just fix that. Okay. So select app name category from Playstore apps. It's a pretty heavy query. I think it's going to execute to get all the rows, then add a limit. Okay, let's go back and see. Let this run back here. Select app name rating from apps where free equals true and rating greater than 4. Okay, let's try this. I think I've frozen the editor. Let's see if I break out of it. Not really. Yeah, I think it sort of froze up because I hadn't added a limit. But now when I add a limit of 10, it works. I mean, it would have worked also, but uh, better to sort of write a limit. Let's look at the filtering query. So we go back here. Also add a limit. Good. Oh, yeah, this is the one. I think we can make that change when we prompt GPT to say that the write queries with the app with the table name being Playstore underscore. So it says operator does not exist, integer equals boolean. Okay. Why is that? Structure free is an integer. When I come back here, 0 and 1, free will go back. I think GPT made a mistake when it created the table, the create table query. Let's see what that was. It said free is boolean. Okay, maybe we change that. Go back what it did. So that's why we have this issue. So free equals 1. So I get app name and rating. Let me also. Yeah, okay. So these are the free apps whose rating of 4. It's also nice to get the category to see what the categories are. Okay. Go back, see the other queries. There's a sorting. Let's do this one. Okay, so the category, the sum of max installs from apps, change that to store apps, where free equals 1, group by category, order by total installs, send. So the most number of total installs, and then below that. That's a pretty large number. Right. Okay, probably it's across all the apps in that category. So you have category and maximum installs across all the apps in that. Got it. Yep. I think you have a tutor or ChatGPT as a tutor that can allow you to learn from these queries, right? And you can also sort of write back and say, okay, given the query below, modify the query to include number of apps for each category. And you can see that it sort of gives you the count function, tells you what the count function is. You'll need to use the count function in addition to the existing sum function. The modified query will count the number of apps in each category, sum their maximum. Okay. What I think the most important thing is in this query, and then looking at the explanation, there's a lot of information provided here. I think that's important to understand as you're learning SQL, especially. Maybe once you have some of the knowledge already gained, you don't have to read through this, and your query itself will be self. This time I want to get by number of apps. One has the most number of apps. Oh, this again. Okay. Category education, number of apps. I think I guess I want to know what's the average number of maximum install. Just to get a sense of, is that really the number that we can expect? Total install. we'll go with average. Why don't ask ChatGPT? Say, how do I write the query that also includes the average number of installs per app? Let's see. It says in each category you can use the average function in SQL. Function calculates the average of a set of values. Okay, so we continue with the count app name, sum max installs, and the average max. Quickly make the changes. You don't have to actually make these changes. I think when you actually use it yourself, you can just say create table itself can be modified to ensure that the column name free is integer and the table name is Playstore apps. I didn't make that change, but you can when you are using. Okay, average installs per app. Well, I don't think every app, or at least the average, is going to be. The average is this high, perhaps, because there could be a few apps that are just breakout success. They've been installed so many times that they're sort of pulling the average towards them. That happens when you have outliers and things like that. So you can go back to ChatGPT and say the average seems to be influenced by very large or very popular apps. Is there a better way to identify the most likely number of max most installs per app? I mean, it is usually the average, but in this case, average is sort of goes heavily. So it can skew the perception of typical app popularity within the category. That's exactly right. To get a more representative measure of typical installs, you might consider using the median. Okay, so I get the median. Common approach is to use subqueries and window functions, but the complexity of this approach can vary depending on the SQL database. Right? So what did it do then? Percentile count, UNT, by within group order by maximum installs, over partition by category as median installs per app. And for those of you who don't know what this means, I think there's also a great explanation. Well, I don't know if it's great, depending on how well you understand it, but let's go what you were saying. Calculates the median 50% of maximum installs for each category, over partition by category, partitions the data by category. So the median is calculated separately for each category you want. The other parts of the query remain the same, providing count, total installs alongside. Okay, right, try this. Well, actually, I just need to get this one. Over is not supported for ordered set aggregate percentile count. So what we could do is take this, go back here, just prompt ChatGPT with it. It seems like SQL database doesn't support over with the percentile count function. In such cases, calculating the median requires a more complex approach, often involving subqueries. Here's an alternative method. Let's see what the method is. We'll have to, I think if you're going to start learning SQL and you get to this point, you might have to spend some time on these queries, right? I think it's the right approach, because obviously when you're doing an analysis that I just started out with, you might end up with a question where the average looks very odd, looks very large, and then you might want to represent it with a median or some kind of a percentile. And then this is exactly where ChatGPT will take you. And you'll have to go back and forth, right? You'll have to go and try a few things. So let's see. We'll start with the first CTE, which is a common table expression. it says select category, maximum installs, row number, partition by category, order by maximum. Okay? And count over partition by category, the total count from apps, for free apps. Then the median is really select the category, max is when number, RNSC, the row number, when the row number is in total count, or total count 1, then max installs and add. Okay, from ranked, it's trying to get like the halfway point, the row number. So the median, if you have 50 items, the median is the value, which is the average between, let's say, 25 and the 25th and 26th value, right? Because you have like, if you have even number, you have 50, you can't divide that set, and you'll have sort of like, well, you can actually divide that set, but you'll have 25 on both sides. The value is going to be the average of the 25th value in the first set and the 26th value in the second. You have like 51 items, you could just the 26th value and 5 on this side, 25 on this side, 50, and then the value in the middle, you have odd number. Okay, so this is what we have. Feels like this should pass test, and ensure that mistake that we made earlier fix. This one is using the CTE change there. This one I need to make a change. All right, let's please wait, queries execute. Okay. Yeah, and I think the query gives me the right answer. You can see that at least for first row, I have tools as a category with 57,000 apps. A large number of total installs, the median installs being 1,743. That's a pretty good number. Probably sounds believable. Obviously, you can dig deeper by, looking at the number of taking a number where, let's say, you have a racing or a category where you have a fewer set of apps, and then just ensuring that, sorting it, getting the row number, going to the middle point, and then looking at the number, sort of matching with the results here. I expect this to be right. So there is no need to doubt this, and the approach looks correct to me. And there you have it, folks. I think with this Docker image that I've created, you could get started immediately. You just have to install Docker on your Mac or Linux or Windows machine, and then once you get started, ChatGPT is your friend, right? Or GPT 3.5. I don't use a lot of 3.5. I usually, for the most part, just use GPT-4, and it has been a game changer for me to learn anything. And I wanted to showcase that with these sort of Docker images, you can roll your own environment. I think my on my roadmap is to add more data sets to this Docker image. If you have suggestions, please comment in the YouTube comments about the kind of data sets that you like to see, more about how do we use GPT-4 to learn SQL, and so on and so forth. Right? I'd love to do another video on this, but this has been very useful. I told a couple of students I mentor, they found this to be it was very viable for them to get started. And then when they go and look at other courses, right, it actually is a more productive approach where they come back, they can use GPT-4 as a co-pilot or a or somebody, or not somebody, hard to not personify it, but as a co-pilot entity that could help them learn SQL. And the iterative approach is very important. You don't just take the query from GPT-4 and then run it and assume that you've learned. I think that would not be the right approach. What you should be doing is, let's say you take this query, or maybe just go back and say, explain step by step what is happening in the above query, in the query, assuming I think it's the previous one. Query provider is a bit complex as it uses common table expressions and window functions. Now, one of the things I like to do is go and start researching common table expressions. Immediately just Google search it, read about window functions, read about what is a median, what are percentiles, right? And don't just depend on what is being mentioned here. Take this and do more research. It says the first part of the query defines a CTE named ranked apps. A CTE is like a temporary result where a result that you can reference within a SQL query. In ranked apps, the query filters the apps to include only those that are free. This is here. And let's say this is ranked apps, right? It's named ranked apps here. Partitions the data by category so that each category is treated separately. Partitions the data by category here, right? For each app, it assigns a row number based on the order of the maximum installs within each category. And this is the order that's in ascending order. So if you want it to be descending, you'd mention order by maximum installs descending. Counts the total number of apps in each category. Get the row number, get the count for each category. Step 2, creating the medians, CTE. The second part defines another CTE named medians. Okay, select category. Just read uses the data from ranked apps. So the data that you get with this query is assigned to this variable or this name ranked apps, the CTE named ranked apps. And the second query, well, not the second query, the second CTE actually references ranked apps. Sort of like a virtual table. I mean, it's not the right terminology, but there's a table created of the results of the previous CTE that the next CTE can actually reference. Pretty powerful. So here, select category, max case when this this column is coming in from the column that you created here called row number. Okay. And okay, so for each category, it finds the row numbers that would correspond to the median. This is done using a case statement within a max function. Case statement checks if the row number is at the middle of the dataset, total count by 2. The max function is used to pick the maximum installs value corresponding to the median row number. Final query, the final part of the query combines the results from CTEs with the original apps table. This part of the query, we join the medians CTE with the apps table on the category field. Filters to include only free apps, right here. Calculate the total number of apps, the total number of the installs for each category. Use the median installs per app calculated in the medians CTE one. Groups the results by category and median installs and orders them by total installs in descending order. There you have it. I think this is a very good approach for many people. I wouldn't say this is the best for everyone. I would probably augment this with, let's say, access to a tutor in real life, or some kind of an online course, right? But it would be important for me to come back to doing my own experiments, learning as much as I can on my own with GPT. And then when I go back to a real sort of like a tutor or an expert, I have better questions to ask them. Okay? I could ask questions like, hey, is RCT is really the optimal way, or subqueries, for example, if that is a question that I may have come across on research. Or I may say, hey, you know what, I think I have a way to try different things out. What are some interesting data sets out there that you recommend to look at? So please check this video out, right? And do some of these things and write back in the comments. I'd like to know how it worked for you, and if there's any other items you would like me to discuss in subsequent videos. Thanks for your patient listening, folks, and see you in the next video. Thank you.